Hello everyone. So we are gonna talk about this problem. So this was actually the last question in the given worksheet that we had. So I feel this is a bit challenging for most people. So which is why I like to do this like video. Okay. So we are given the one square PQRS, and then 2 points on that square is given right here. And based on we are gonna talk about this. Okay. So just to kind of feel how that looks like, maybe I should have something right here. So, if you have a square, the things that you need to remember, the each angle is 90 degrees. So that is actually kind of the point of this picture. So let me say this is like P, and then this is Q. So when you start writing those letters, so you need to follow the either clockwise or counterclockwise, but you need to follow the given orders. Okay, so if I go with this P, so that means this could be Q or this could be Q, but it doesn't matter which one you go because you can always rotate it. If this is Q, then the next would be R, and the next would be the S1. So if I go with this direction, so that will be okay as well, but I need to keep those four letters order the same, okay? So it doesn't matter, but it just kind of, you don't have to graph this one, but it's just there for us to remember. So then these are 90 degrees. Okay, so the question has 2 points, P and Q. So if I kind of connect those 2 points, right? And you don't really know how the other 2 points will look like. So if I have this is the one side, so you could have something maybe like this because you are gonna get a right angle in between two sides, like, and every vertex you will get 90, but it might be on the other side as well. So you might be expecting something like this, but at the end of the day, so it doesn't really matter because we don't really care how that looks like in the current plane. So we just need to know the equation of stuff, okay? So, but for the sake of kind of visualization, I will actually assume the other point is going to be something right here. How do I get that point, even though the question wasn't asking? From this point to this point, so you have 2 units right, 3 units up. So if I go 3 units right, and then 2 units down, so I should be getting like this point. So maybe this is just the another one. So again, it doesn't have to be right here, but if I have this, like this is 3 units, this is 2 units. So we have 2 units and 3 units, so you can make a right triangle where the hypotenuse is the side of the square. You can just imagine this is the next point. Or you could do the other way around. So, this is 2 to 3. So if I go with like 1, 2, and then 1, 2, 3. So you could have this point as well, but let me actually do it in a different color. So you could have this one, right? So this is one point that you could have, or this is another point you could have, and then I think the rest is easier. So you can go 3 units below and 2 units left to get the next point. So let's keep the colors same. So that is gonna be my square. Again, we don't really know if this is the point or this is the point, but it doesn't matter because if I do the other way around, the slope or the equation will not change. So then you can do same thing with the other option. So you can take one of these, so which I will take the red one. Okay. So if this is P, this is Q, then that means this is R, and this is S. If this is PQ, this would be R, this would be S, but I'm gonna use this guy, okay? So let's go back to the problem. So what is the equation for the line contains Q and R? So Q is right here. This is P, so this is R. So what we know is, without graphing, the slope of this PR. So let's go ahead and do that. So the slope was the difference of the Y's, right, over difference of the X's. Okay, so based on that, so for the choice A, so the slope of the PQ, I would say, is it gonna be the difference of the y? So this point is like, we are actually told this 3, 4, and then this is 1, 1. So 4 minus 1 over, so this is y, so x is 3 and 1. So that will be 3 over 2. So you could do this as rise over run, because from this point to this point, you want 2 units right and 3 up. So rise is 3, run is 2. So that's the slope. But this is the slope for the line that goes through P and Q. So which means if you had a line like this, so that would be the line that you have slope of 2 over 3. I mean 3 over 2. But the question says equation, right? For the line goes through Q and R. So which is why we like to find a line that goes through Q and R. So when you say about the equation, maybe I should have said before. So we actually mean usually a couple different forms, but mostly we use mx plus b form because it is telling us the slope immediately and the y-intercept. So which is we use that. So, but this line PQ and QR are two lines are intersecting at this corner where the angle in between is 90 degrees, which means those two lines like PQ and QR perpendicular. So if you have two lines are perpendicular, the meaning of that their slopes are negative reciprocal or opposite reciprocal. What is that supposed to tell us? So when you multiply the slope of the first line, which is PQ, and the slope of the second line, you should get a -1. So that was m1 times m2. The product of the slopes is going to be -1 if those two lines are perpendicular. And now we sometimes use this one, or sometimes you just say take the negative reciprocal, because that's exactly what's going to happen there. So if this is the slope of PQ, then the slope of QR is going to be, you just flip this fraction, which is 2 over 3, and then change the sign since this was positive, so it has to be negative. So now we know the slope of this line, so then I will just write the equation as y equals mx plus form. So y, like the slope is -2 thirds, so that is plus b. So to get our b, I can just choose a point on that line. So that could be R, that could be Q. I'm not going to use this one because I got this myself, so it wasn't given. So maybe it's better to use Q, so which is 3, 4. So if you replace 4 for Y and then 3 for X, so you should get -2 thirds times 3 plus B. So these guys nice to cancel each other. So you get -2 plus B is 4, right? So 4 is -2 plus b. To get b, I can add 2 both sides, so that will be 6 is b. So now we have b is 6. The equation is right here, so it's gonna be y equals -2 thirds x, and then b is 6, so it should be plus 6, which is actually correct as you see. So if you draw a line going through Q and R, that line should go through 6, which is right there immediately. So we don't have to do this much work because it was kind of obvious from this picture. But it's good to know this one because if you don't have the grid, so you can actually get that in anyway. So that's the first one. So I hope that makes sense. And the second one is the equation for the line contains SP. So the P is right here, S is going to be either right here or in that corner. So, but it doesn't matter. This line, PS, is perpendicular to PQ. So we already know the slope of PQ is 3 over 2, meaning that the slope of PS or SP, okay, has to be the opposite reciprocal or negative reciprocal of slope of the PQ, because PQ and PS will make a 90 degrees in this corner, so they are perpendicular. So it's kind of the same as this one, so that should be -2 thirds. So this is one way to say, because this line and this line are perpendicular, the slope of PQ and PS has to be negative reciprocal. That's one way to get this guy. And second way, the QR and PS are actually like parallel line because this is like square. So if you have two parallel lines, the slope has to be same, which means QR and SP should have the same slope. We know the slope of this guy was -2 thirds, so that means slope of this guy will be also the same thing. So as you see, we can get that in 2 different ways. As soon as we have the slope, we are going to just do the same thing as we just did to write the equation. So let's write that. So the y equals -2 thirds x, and then plus b. B is the y-intercept of this line. So which expect to something right here, which is like, looks like smaller than 2, but let's see. And to get that, I will need a point on that line, which we already know p is 1, 1. So let's plug that. So 1 equals negative 2/3 times 1 plus b. So this is going to be negative 2/3. So if I add 2/3 to both sides of the equation, so these guys will cancel. You get 1 plus 2/3 is b. So that will be 5/3. So now we have the equation as, maybe I should write here, y equals, the slope was negative 2/3, and then times x, so that number is my slope, plus b, which is 5/3. So 5/3 is like almost 2, but it's not. As you see, based on my figure, that was the case. So as you see from this picture, you don't really need this whole picture at all. Without having the picture, you could do those, but seeing this picture is kind of easier to deal with. And then we are done with B as well. For the last one, it's kind of challenging, I guess. PQ and QR. Okay, PQ. So PQ is this guy. So let's try this one. And then QR. So QR is this guy. Okay, so this line and this line, are these two parallel or perpendicular? It's kind of obvious from my picture that this is one side of the square, this is the other side of the square, so they're intersecting at this corner, so they has to be perpendicular. So we can say this is perpendicular. This is one way to say they are perpendicular from the picture. And it says write an equation using these slopes that proves your choice. So if you remember at the beginning, I said, if you have two lines are perpendicular, this product of their slopes is actually -1. So let's see, the slope of PQ, which was this guy, is 3/2. So slope of PQ times, I'm going to call this C, times slope of QR. This has to be -1, right? In order for them to be perpendicular. So let's see if this is the case. So slope of PQ is 3/2. And the slope of QR, which is like -2/3. This has to be -1. If you multiply these two, you get 3 and -2, which is -6. 2 and 3 is 6. -6/6 is actually -1. So that is actually correct. So then we are done. So if you multiply two slopes and if the product is -1, that means they are perpendicular. So another way of saying this was, if two slopes are negative reciprocal of each other or opposite reciprocal of each other, then they are perpendicular. Those two lines have those two slopes, has to be perpendicular. And that is just another way to say it, okay? So I hope that makes sense. I'll see you next time.